Alright, this is part 2. We will be assembling the central electronic stack, starting with the power distribution board, PDB. These are going to be our battery outputs, where we'll hook up our ESC power along here and some little supplemental ones that will power our BEC. Main battery, positive, is going to go right here and negative right here. Before we just start soldering wires, I'm going to tin the pads we'll be using, and that will just help us out later. So right now my soldering iron's heating up. If you're new to soldering, basically high heat and quick contact is the best way to get good solder connections, and making sure we keep this tip nice and clean. You can use a sponge and water, or my favorite is the brass wool, not steel wool, but brass wool. Keeps the tip nice and clean. So I'll go ahead and heating. So if you can see that, I'm just adding some solder to these pads, because it's much easier to solder wires onto pads that already have a little bit of solder working with them. This iron is not the best for soldering big pads like this. You need a lot of heat. And this solder is very thin. Remember, always wear safety glasses when you're soldering. Oh, I almost forgot. Pardon the sound, but I'm going to turn a little fan on. Make sure you're doing this in a well-ventilated area. So I'm going to turn this on. So now when I solder, the fumes are going to get soaked up into the fan. I'm going to do the little ones here, right here, and right here, because I'm going to be attaching our BEC to that later. The solder I'm using is definitely not designed for big pads like these. It is very, very thin. this pad right here is huge. The main battery ground. I think my little soldering iron and little solder is going to struggle quite a bit here, but yeah, it does not want to stick. Alright, let's see here. Alright, well, that's going to have to do for now. Alright, I'm going to solder the main XT60 power cable where the battery's going to plug in. This is definitely a little too long, so I'm going to shorten it up a little bit. And I'm just stripping these wires. And I'm also going to tin the wires to prepare them. Steal one of these. It appears to be on there. So I did not cut the wires here. Forgot to account for the little gaps here, so it's going to look a little inelegant, but it will still accomplish the same thing. Alright. Looks like that's soldered on. We'll go ahead and solder the BEC. We'll pick this side, sure. So I just realized I didn't hit record, so I kind of rewinded the clock a little bit, so there's going to be some stuff a little bit done, but we are going to be putting the flight controller on to this board. So it just snaps on just like so. We will use these screws and screw it on. Alright, so the flight controller is now screwed onto the carrier board. It's not going anywhere. Next we'll be mounting it onto the PDB. And how I'll be doing this is I'm going to take this screw, use one of these little rubber vibration dampener gummies, and a standoff piece. And I'll just be slotting in the little vibration dampeners on these little corners here, just like so. And that will help reduce vibrations coming in from the motors, the carbon fiber vibrating and all that kind of thing. So this will help reduce some of that. Alright, I'm just going to flip this so everything doesn't fall off. Okay. I'm going to use these little nuts. They have that little built-in rubber material, so it's like built-in Loctite. Alright, so now that's mounted. We'll plug in the power to the flight controller. This PDB has two power outputs on the left and right, and we will get our voltage telemetry, so we'll be able to see how much battery we have remaining while we're flying, as well as have an entire redundant backup. So if this side of the circuit fails for whatever reason, we have this one here to keep our flight controller nice and powered. Now, this is the part that didn't get recorded, but basically I set up the RFD 900 and split up the cable a little bit to separate power. Important note, just to elaborate a little bit on why we're splitting the power and ground off of the JST for the RFD 900, is you actually can power the radio right from the flight controller's carrier board. However, since it is a relatively higher current draw device, you run the risk of browning out the flight controller and the drone would then fall out of the sky. So we want to have that powered separately by the BEC. A good idea before you plug stuff in, if you're making cables or if this cable doesn't have, you can plug it in any which way, is to make sure the pinout. So this is the pinout for the RFD 900. Basically, you just need to check that, okay, which one is ground, which one is power. Okay, I'm going to make sure that this cable is plugged in correctly, and that I make the appropriate changes to the cable. So as you can see on the diagram here, we have a 5-volt USB on the bottom side of the pins here. So that is going to correspond to the secondary rails right here on the bottom, and then ground right here. This is the orientation for the cable. And if you take your ground and you trace it all the way to the JST, you'd find that. And the way you de-pin these is each one of these pins is held in with a little plastic clip. You take a razor or a needle or a tool and you kind of pull it back. You pull it back, you can just pull it right out. So I did that for ground and for power. And then I cut up an old servo cable and I took off the signal because we don't need it, and I soldered it on here. I am electing to use the flight controller's output rail as kind of my power distribution for the radio here and for the Raspberry Pi. Reason being, you know, if I decide to take the radio off later, I don't have to desolder anything. Same with the Pi. And then if we add any cool sensors later that require some extra juice, we can just plug them on here. I also only have the one BEC. I think your kit might come with two. Don't quote me on that though. Another thing about the main out here is I have no idea what is power, ground, and signal. It's not labeled on here. So again, you know, we want to look up what kind of carrier board we have and append pinout search, and you should find it. So here it is here. We can see that the top is ground and the middle section is for 5 volts. So I can find a open spot in the middle to plug the BEC. Same with the radio. Other reason I'm doing this too is so that these are sharing grounds as well, which is always good to have. And in order to power the Pi, I took the other side of that servo cable from here and I soldered it onto a cheap USB-C cable. The cheaper the better when it comes to modifying these, because you know this one just came with some random cheap electronic that was just for charging, no data. I snipped off the USB end, and you know these cheap ones, all they have is power and ground, so it makes it really easy to tell where you're soldering to. So made this cable. I'll pick a spot for that. I will plug in the Raspberry Pi, and the reason I am using a USB-C cable for the Raspberry Pi is typically that's the best way to power these. You can power it off of the GPIO pins. I'll pull up that graphic. So yeah, you can power it off of the GPIO pins. However, it's a little bit better to power from the USB-C. It's just more of a dedicated way. There's more, you know, built-in protections, etc., etc. Important note and a little bit of context on this: the GPIO pins and the wires that typically go along with them aren't really designed to handle the amount of power that the Pi could fully draw. So that's why we're using USB-C. Additionally, because we are using USB-C, and this is not a power delivery cable. There's no negotiation or handshake that the Pi will do with the connected power supply. So we're going to have to tell the Pi that it's safe to use the full 5 amps from the power supply. So stay tuned for that in the Raspberry Pi setup. Alright, so going to do a little power up. I already did power this, so I can confirm that it does power on, but still, just to be safe, I will be using the included smoke stopper. So this is a lifesaver if you have anything connected in a way you shouldn't. It's just not going to work, rather than it burn up and let out a ton of smoke, or at least less likely to. So I'll go ahead and power this, or plug this in, and get our battery, and I will check our battery cells. Just want to make sure that they're all roughly the same. I haven't even charged this since I got it. It's brand new. Alright, we'll plug it in. You can see lights on the PDB, lights on the flight controller, lights on the radio, and lights on the Pi. Everything is looking good. If you can hear that sound, I'll bring it a little closer to the mic. That is coil whine from the inductors, or it most likely is from this BEC. Nothing to worry about. Doesn't sound great, but no harm there. So we missed a interesting find while I wasn't recording before. Was the first battery I tried actually has a bad cell. So I had just opened this battery. I went to just double check everything. You can see 3.8, 3.79, 3.8, 3.8, 2.8. So this cell 5, is under 3 volts, which for a LiPo battery is pretty bad. Anytime a cell goes under 3 volts, it's generally unrecoverable. So this battery is no good, and always a good thing to check before you power on or charge a battery after you first buy it. Alright, so we are going to next solder up the RC receiver, the little Express LRS module. So here's what we're working with. And it comes with some heat shrink, which we will definitely want to use in a bit. I'm not going to bother with these pins. I'm just going to solder direct. And we will be making a JST connector. So this should go into, we'll pick telemetry 2. Click it in there just to do a little sanity check. So you might be able to see we have RX, TX, 5 volt and ground. So we'll choose red for 5 volt. Blue and green for RX and TX. And black for ground. Sorry, strike that. I am going to solder this on because I just realized we can use these for a really nice connection. Okay, that's totally what I'm going to do. Want to make sure you're giving heat to both the pin and the pad so we get a good connection. We will pin up the connector, so we'll pick, we'll go with RX is green, just gonna push it in there and it'll click in. TX is blue. Next is 5 volt. And then ground. Just like that. And now I can plug it in. Oh, so nice. Sweet. We will do the same. We will click these into the JST, but we have to figure out what the pin out is. So, let me see. Here's the pin out for Telem 1 and 2. So we'll have to make sure we match that. The little red icon is just a way to help line up, where pin 1 is. So pin 1 is 5 volt. I'm just going to try to use this for reference here, just to make sure that we get this right. It's very easily to kind of disorient yourself when working with these JSTs, or at least for me. Just click right in. These are definitely trickier to pin than these big ones, but it's still doable. So next, pin 2 is TX, and when we're wiring things like this that have an RX and TX, we want to flip them when we connect. So right here we have green as RX, so RX on here is going to go to TX down here. And then TX will go to RX. And reason being is, when this RC receiver is transmitting to the flight controller, it has to go to the receiving side on the flight controller and vice versa. So if you power this on and it seems to be getting power but you can't talk to it, sometimes it's because you flipped RX and TX. Alright, and that's in, and then we'll skip 2 pins because we're not using request to send, clear to send, and the last one is ground. Note on receivers and any radio system, whether it be RFD, RC, or any other, when you power it on, make sure you're powering it on with antennas. The analogy I like to give is when you power on a radio without antennas, it's like screaming with your mouth closed. It just doesn't go anywhere, and it's like when a kid doesn't get their way and they pout and make their face go red. It's really bad for the radio. So we want to put the antennas on. These snap on, little UFL connectors. And I'll go ahead and click this into LM2. We'll do a quick power test of the smoke stopper. And we have power. Now that we have power, I'm going to, well, we know that works. I'm going to heat shrink this. This will kind of give it some nice protections. Alright, I think it's time to start mounting stuff up to the drone. Try to get it as lined up as possible. Is mount this to the battery. Alright, so I fed this through. I'm gonna put it on out here first, just to make my life a little bit easier. Screwing it in. Now, it took me a while to find screws like this. I had them lying around, but they're appear to be M2.5 screws, which aren't necessarily uncommon, but usually these M screw kits will come in even sizes like M2, M3, 4, etc. I don't know how well these are actually biting into the 3D print, but you know, at least it'll help this not back out when you plug in and out the battery. When picking spots to put radios, just keep in mind that carbon fiber is conductive, so we don't want to, slap it on the bottom. We want to try to keep it as far away from carbon fiber as possible, but it is not a huge deal. Here's where I'm mounting mine. Alright, here's a little trick that I'm gonna do, because with antennas, with diversity antennas like these, we don't want to have them on the same plane. So right now they're on the same plane. You can think of the signal coming off of these or receiving being like a donut shape coming from here. So it's a donut shape around here. So we have two like this. They're going to be receiving in the same pattern or transmitting in the same pattern. So we actually want to have them like this. You know, so those donut shapes are now kind of a X. Gives us the best chance to get some good range in whatever orientation we are. And I'm going to put a dab of glue here. I'm just going to glue them in a little X. Ideally, you kind of separate them a little bit, but that's okay. So that's where I'm sticking the RC receiver. And I'm doing this just to kind of make this antenna a little more rigid. Now it's sticking out of the frame, so that should give us some good quality signal there. I am, however, going to check that the props aren't going to hit that or anything. These are the props I was provided, so I don't know if you'll be getting the same one, but it's always good to check because we wouldn't want that to happen. Feel free to get creative with how you mount your antennas, but this will work. Now I need to add a couple of these standoffs just to give myself a little more room. While we have this pie out, we're going to put on the cooler. So we're going to pop off this little bit. Peel this off, leave these on. These are little pieces of thermal tape. And we want to line up this with this hole, the other one with the other. And we'll push. And we'll push the other. You can see that pops through the other side of the board. And we will plug this in. Like so. there's the GPS. We want to make sure this arrow is pointing forwards, the same as the arrow pointing forwards on the flight controller. If you already stuck it on and you don't want to take it off, that's fine. We can change that in software. This is a CAN GPS, so we gotta find CAN 1 or CAN 2. So I will go ahead and plug it in right here, corresponding to CAN 1. Alright, this is starting to look like a drone. Let's do one last power check. Well, the smoke stopper is not going to fit anymore, but it's okay. We already did a smoke check. Alright, powering on. You can see the Raspberry Pi fan is on, all the lights are on. Once we set the GPS up, the lights will keep on. Let's check. Yep, our RC is on, and RFD 900. Hard to see the green light. You can kind of see it. That is on. Alright, well that completes part 2 of the central electronics. Next part, we will get the motors and ESCs wired up.